Hi, folks. Welcome back to Physics with Captain Rod. I'm making this video here to provide an example of how to apply impulse momentum methods using impulse and momentum diagrams. Now, this is basically a trivial example, but it will demonstrate the methods reasonably well, which will then extrapolate to more difficult problems. So what you do when you want to apply impulse momentum is you draw what's called an impulse momentum diagram. And the diagram is based on this fact. The initial momentum of a system, I'm just going to put here, like mom1, plus any impulse acting on the system is equal to your new momentum. I'll call it mom2. Now keep in mind that these are all vector quantities. Momentum is a vector concept. So this ball here at picture A, it has a momentum up and to the right. Now this is a velocity vector. And it's not technically a momentum vector yet because a momentum vector needs to have a mass in it. So what I'll do here is I'm just going to throw another vector on top of it right here. Call this mass A, velocity A in picture 1. Okay. Now, whether you draw the vector longer or shorter in this example, it doesn't actually matter because it doesn't even make sense to compare the lengths. This first vector has units of feet per second. My vector has units of kilogram feet per second. They're not even the same thing. Okay. The next picture we draw is the impulse picture. So I'll go ahead and just draw it kind of in the middle here. So here's the ball somewhere in the middle. And the impulse picture really is just a free body diagram. You just tack times on to make them impulses. And if we ignore air drag, the only force to worry about is the gravitational force. And as I see here, I haven't had all my coffee yet. I really don't need the A here on that mass because there's only one mass in this problem. That wasn't really mass A, that was position A. My apologies here. Again, I'm just getting my coffee for the morning. All right. Now, position B here, we're at the highest point in the picture. And what that means is that as far as the velocity is concerned, the velocity does not have a y component at the highest point here. So our momentum vector points this way. M, V, we'll just call it at B here. Really didn't need the 1 on here either. The A is the position. Okay? So again, what you do to draw an impulse momentum diagram is you draw the system at the first state and you draw its momentum vector. And you can either do it in component form or like I did, magnitude direction. Then your second picture, you draw the forces on it and then you tack times on. Oh, I see, I forgot to do that too. You tack a time on, some sort of delta t here to make it an impulse. Now it's perfectly fine to just put delta t when these forces are constant. But when they're time variable forces, the impulse looks like this. It's an integral f dt if we're talking time variable here. And then you draw your momentum vector at the second time. Okay, once you get the pictures done, the equations basically write themselves. So now we'll talk about momentum in the y direction because remember, momentum is a vector concept. So I'll put momentum y direction up positive, and we look at our picture and the initial momentum component in the y direction would be mva sine 30 degrees because we would want the y component of that momentum vector. Okay. Now we look at our impulse diagram. We've got a downward impulse of mg delta t, so I'm going to put minus mg delta t. All right. And now we look at our at our third picture, which is our momentum at position B. And again, remember, we're applying this by direction. These are vector quantities. There is no momentum in the y direction. And there you have it. That's how you, 1, draw an impulse momentum diagram, and 2, use it to write a momentum equation. And in this particular problem, I think it's said to solve for t. You'll notice the masses divide out. If we solve this for t, we're going to get, mass divided out. VA sine 30 degrees over G. I'm going to let you folks put in numerical values for this and just call that a day video-wise. So the point of this video is how to draw impulse momentum diagrams and then use them to write momentum equations. I hope that this has helped do that for you. Have a great day.